So now we're ready to work on our KCL equation. I1 plus I2 plus I3 sum to 0 when we look at the KCL equation in node 3. The way you do this is you express each one of these currents in terms of voltage divided by resistance, and that's something from Ohm's law. So what I want to do is label the node voltages. So we'll do that in orange. This is V1, node 1 is V1, this is V2, and this is V3 here on node 3. So let's see if we could express I1 in terms of V1 and V3. I1 flows through R1, and the two node voltages on either side are V1 and V3. So just using Ohm's law, we can say that I1 equals, it's a V over R term, so it's V1 minus V3 over R1. Now, how did I know to put V1 first in the subtraction here? The reason I put V1 first is because I1 is flowing into R1 from node 1. And from the sign convention for passive components, that means that V1 is the more positive voltage compared to V3. So you look at where the arrow points in. In this case, we drew the arrows first. Then V1 comes first in the subtraction, and then V3. Now we'll do the same for V2, or for I2. I2 is V2 minus V3 over R2. V2 minus V3 over R2. And finally I3. I3 flows in from 0 volts and flows towards V3. So it's 0 volts minus V3 over R3. So these now become the three terms in our KCL equation. Let's write it all out here. V1 minus V3 over R1 plus V2 minus V3 over R2 plus minus V3 over R3 equals 0. And our job right now is to solve this equation. Now there's some things we know here. We know V1, we know V2. Remember, we worked those out earlier. Those were easy. There's 3 terms of V3 here that we have to, that's what we're looking for. And there's the R's are given to us in the circuit diagram. So let's go to work on this. I'm going to roll the screen up a little bit and we'll get to it. So let's fill in the voltages that we know. Okay, minus 11 volts minus V3 over R1 plus minus 11 volts minus V3 over R2 minus V3 over R3 equals 0. Since we're putting numbers in, let me put in the numbers for the resistors. All right, R1 is 1.4 ohms, R2 is 1.4 ohms, and R3 is 2.7 ohms. And to simplify this a little bit, I'm going to multiply through this equation by 1.4, and that'll clear out R1 and R2. Let's do that. I'll get minus 11 minus V3 plus, minus 11 minus V3 minus V3 over 2.7 times 1.4 equals 0. Now we'll gather the like terms together and put all the constants on the over there on the right side. So I get minus 2 times V3 that one and that one, minus 1.4 V3 over 2.7, and that equals 22. Let's clear out this fraction by multiplying everything by 2.7. So we get minus 2 times 2.7 times V3 minus 1.4 times V3 equals 22 times 2.7. This term here in the parentheses evaluates to minus 6.8. And so V3 equals, let's do this, kind of squeeze it in, 22 times 2.7 divided by negative 6.8. And if my calculator is right, that comes out to minus 8.74 volts. V3 is minus 8.74 volts. So let me roll back up and see what that means. Let's label our schematic. So V3 we said was minus 8.74 volts. Oh, we get to check off some stuff here. Let's check off that and that. So now we have all of our node voltages. V1 is minus 11 volts. V2 minus 11 volts. And V3 is minus 8.74. And now your last question is, what is I3? That was the original question. What was I3? So we have the voltage on both sides of R3 here. We have 0 volts on this side because it's the reference node. And we have minus 8.74 over here. So let's use Ohm's law to figure out what I3 is. I3 equals, it's going to be a voltage term. It's going to be 0 volts minus negative 8.74 divided by 2.7 ohms. 2.7 ohms. And that gives us I3 equals 3.24 amps. So we have 3.24 amps flowing, which way? Flowing into the resistor going in this direction. And if you look back at the previous video, that should give you the same answer.